Hello from Dennis Coskren, the local geology expert. This coming weekend, that is a week from now, I'm going to be giving a talk in central New Hampshire on the great Belknap supervolcano, which of course nobody's ever heard of because it last erupted about 160 million years ago, which means it's probably pretty safe. You're about as likely to be attacked by a Tyrannosaurus Rex as you are to be caught in a new eruption of this volcano. It basically is very, very similar to Yellowstone in that it's the site of what's called a supervolcano, and that is there is what's called a plume of a very, very hot solid rock coming up perhaps almost all the way from the core, a couple of thousand miles deep. And when it approaches the surface, it partly melts and sends molten rock up into the crust. The molten rock, though, is basalt and mostly doesn't make it to the surface. Instead, it melts the rock of the crust near the surface, and that's what does the erupting. This is what's happening today at Yellowstone, and every few 100 million years, like 640 million years ago at Yellowstone, was the last big eruption. When that happens, the magma or lava, underground lava that's in the crust comes out in an enormous explosive eruption, empties out the magma chamber, and the top collapses into the chamber. Now, that's what happened here 160 million years ago. That's what's happening today at Yellowstone. Now, Yellowstone is very nice in a way because you can see what's happening on the surface today and what has happened in the last million years or so. You can't see what's going on 5 miles deep because that's all hidden 5 miles deep, covered up by rock. Here in New Hampshire, 5 miles of rock has been removed. So you can't see what was going on at the surface, that's all gone. Instead, you get to see 5 miles deep at the inner workings. And what happens here on this particular rock is that this black rock that you see over on the edge, this is the basalt that is a small amount of it is being squirted into the magma chamber. Now, I don't have it on this particular rock. I've got another rock that I have that I do not have available at the moment, in which you can see the granite of the chamber, which was liquid at about 800 degrees Celsius, and a squirt of basalt came into it from the mantle plume below. The thing is, the mantle plume a rock is made of basalt, which is at about 11 or 1200 degrees Celsius. And when it's squirted into the magma chamber at 800 degrees, that's very, very, very cold as far as basalt goes, and the basalt turns solid. And so that you can see that in the little squirt that came in. You can't get to see that quite here because this doesn't have the granite in it. Now, this particular rock has 2 other rocks shown in it also. These are a couple of 100 million years older. So this basalt is actually closer in time to us than it is to these rocks here. This rock here is called Meredith Granite Porphyry, and it's made up of melted sediments from an earlier series of geological problems that happened when a chunk of land the size of Madagascar smashed into New England, resulting in the deep burying and melting of some of the earlier sediments, making this particular very, very distinctive rock with these large crystals of feldspar embedded in it. That's why it's a porphyry. This rock over here on this side is called Winnipesaukee Tonalite, and that's just a little bit earlier from the same period of geological instability. And so we have 3 separate igneous rocks showing up here. Now, if you'd like to see an eruption like this, think again. You do not want to see an eruption like this. Yellowstone is going to go off again. There have been 3 separate eruptions at Yellowstone so far. The 3 eruptions are all separated by about 600,000 years, so it's very unlikely that it's going to go off in the near future. If it does, probably everyone within 500 miles will be dead, and within 1,000 miles, many of the people will be dead. And there will be worldwide, it will be a worldwide disaster with famines from worldwide cooling and lack of food. There'll be a worldwide winter lasting several years. So, no, you don't want to see it. When this erupted before, we estimate that the entirety of New Hampshire and neighboring states was probably covered by this basalt, by igneous rock, basalt and other igneous rocks. However, we don't get to see almost any of it at all because, as I said, the top few miles has been eroded away of the crust, and that includes everything that was erupted onto the surface. The only place that you can see those rocks is in the crater itself, because when the magma chamber was emptied, the top collapsed into the magma chamber, and that actually preserved some of the lavas that came back out. And so that's the only little bit that we get to see. Okay, and that's it.
Thank you, sir.